In the place value system, the position of each digit plays a part in determining the overall value of the digit. Consider the number 111. It's a sequence of 111. The rightmost digit of a natural number is in what's called the ones place. The next digit immediately to the left of the ones place is in the tens place. And the digit to the left of the tens place is in the hundreds place. To find a digit's value, we can multiply the digit by the power of 10 that corresponds to its position in the sequence. When we have a 1 in the ones place, it's simply worth 1. But a 1 in the tens place is worth 10, and a 1 in the hundreds place is worth 100. These are the place values: ones, tens, hundreds. To see the meaning behind the place value system, we can expand the number. The number 111 is made up of 100 plus 10 plus 1. We can combine these vertically through vertical addition to get back to the original 111. All we have to do is line up the ones place values on the right and then add each column. 0 plus 0 plus 1 makes 1. 0 plus 1 makes 1. And then we bring down the 1 in the hundreds place to get the original number 111. Write the number that corresponds to the sequence 111 in words as you would on a personal check. We'll start with the hundreds place and write 100. Then we'll add the next two digits. Some sequences have a single word name. 2 ones in a row has the name 11. Multiply all the digits of the sequence 324 by their individual place values. There's a 3 in the hundreds place, so we'll multiply 3 times 100. There's a 2 in the tens place, so we'll multiply 2 times 10. And there's a 4 in the ones place, so we'll multiply 4 times 1. Now we can write the expanded notation. After we multiply 3 times 100, we get 300. If we multiply 2 times 10, we get 20. And if we multiply 4 times 1, we get 4. The expanded notation is 300 plus 20 plus 4. Write the sequence of 324 in words as you would on a personal check. Start with the hundreds place. It's 300. Then include the sequence of 2-4, which doesn't have a one-word name, so instead we'll write 20-4. I'll do the first one. In the sequence of 498, we want to start by writing the hundreds place, and that's 400. The sequence of 98 doesn't have a single one-word name, so we'll have to use a hyphen. We'll put 90-8. Then we'll put 4 times 100 plus 9 times 10 plus 8 times 1. This is just multiplying the digits by their place values. Finally, we arrive at the expanded notation, which is 400 plus 90 plus 8. Use these same techniques to fill in the remaining blanks. For 740, start with the hundreds place and write 700. The sequence of 40 actually does have a one-word name. It's 40. Multiply the digits by their place values, so we get 7 times 100, 4 times 10, and 0 times 1. This makes 700 plus 40 plus 0. In the sequence 102, start with the hundreds place and write 100. Then the remaining sequence of 02 is simply written as 2. It's 1 times 100 plus 0 times 10 plus 2 times 1. This corresponds to 100 plus 0 plus 2. The hundreds digit in the next example is 9, so we'll start the wording with 900. And 15 is a one-word name, so we won't need a hyphen. It's 9 times 100 plus 1 times 10 plus 5 times 1. That makes 900 plus 10 plus 5. The previous page provided some practice with writing word names for 3-digit numbers. If you can write 3-digit numbers, then you can easily extend this to larger numbers. For large numbers, a comma may be placed to the left of the decimal after every 3 digits. The place values that matter most for writing large numbers are these: the ones that come at the end of the groups. In order to write a large number, first write the name of each group of 3 digits the way you would as if nothing else were around them. Then we'll additionally attach the name of that group or period. For the sequence of 263, it would be written in words as 263 if there was nothing else in the problem. But since they're actually positioned in the thousands period, we'll attach the name associated with that group, which is 1000. So it's 263 thousand. Take a look at this 7-digit number. Again, for each group of 3, give the name of that 3-digit number as if it were alone. Then additionally attach the rightmost place value of that period. We can insert commas wherever they appear in the number. This number would be written as 1,000,000, comma, 458,000, comma, 20. And we don't have to specify the ones place value. We can leave that off. Try these examples, and then I'll give the answers. I'll start with the sequence of 1, 2, 4, and I'll write 124. But I can't stop there, because that wouldn't be enough. We need to convey the scale of this number. It's much larger than 124. So we'll put 1,000 at the end, and now the size of the number is clear. For the next one, I'll start with the 200. But once again, I can't stop there, because that wouldn't be enough. What we have here is actually 200 million. So we have to put the word million at the end. In the next problem, I'll start with 25, as if it was the only thing in the problem. The 25 is in the thousands period, so I have to say 1,000. Then we can put a comma, and then state the final sequence 351, which would be written as 351. 25,351. Here we'll start with 4. And this 4 is in the millions period. So we have 4 million, comma. Then I'll write 20, but that 20 is in the thousands period, so let's write 1,000, comma. Now we can say the final sequence, which is just 2. 4,020,002. Next, I'll start with 670. But that is in the millions period. We can skip over the thousands period because there's nothing in it. Put a comma, and we'll put 490 at the end. $670,490,000. Write the expanded notation for 58,614. Start with the largest place value digit, which is 5. But that 5 is worth much more than 5. It's in the 10,000s place. So multiply 5 times 10,000. The 8 is in the thousands place, so multiply 8 times 1,000. We have a 6 in the hundreds place, a 1 in the tens place, and a 4 in the ones place. After we've shown the multiplication of the digits times their place values, we can actually carry out those multiplications and get the expanded form. It's 50,000 plus 8,000 plus 600 plus 10 plus 4. Write the expanded notation for 8,900,510. The 8 is in the millions place, so we need 8 times a million. The 9 is in the hundred thousands place, so we need 9 times 100,000. Then we have a 5 in the hundreds place, and a 1 in the tens place. We can actually skip all the zeros. We get 8 million plus 900,000 plus 500 plus 10. And that's the expanded notation. Write this as a single number using the place value system. First, I'll convert it to the expanded notation. We get 500 plus 60 plus 4. And now we want to add these results. So we can use that technique of vertical addition where you line up the ones place digits. Then add each column. 0 plus 0 plus 4 makes 4. 0 plus 6 makes 6. And then bring the 5 down. The number is 564. Write this as a single number using the place value system. We get 40,000 plus 800 plus 10. We can line them up vertically. And then add each column. The number is 40,810.